Hello, ladies and gentlemen. Welcome back to Chapter 12. We are going to be continuing talking about solutions. This is the fourth part in the series of solutions. Okay, today we are primarily going to be talking about factors that affect solubility. In other words, how well things actually dissolve. Okay? The first thing we're going to talk about is temperature, and specifically related to solids and liquids. Solids and liquids act differently than gases for most of these different factors we're going to talk about, so we need to talk about them separately. Now, solids and liquids you are the most familiar with in how they work, in that if you increase the temperature, you increase the solubility. Okay, and if you look at the graph, it directly shows that. And that's simply because solids and liquids both have the atoms and molecules relatively close together, and when you increase the temperature, it causes the liquid molecules to move faster, which causes both the liquid and the solids to spread out faster. All of you know that it's easier to dissolve something in a hot drink than a cold drink. Okay, that's what you're seeing is by increasing the temperature, you increase the solubility. And you saw that with the supersaturated solution as well, because remember, you have to heat it in order to reach that point of supersaturation. Now, gases are different because their molecules are farther apart. Now, with gases, if you increase the temperature, you actually are going to decrease the solubility. Okay, so if you think about a gas and anything, gases are already moving pretty quickly. So if you make them go even faster, they're not going to want to stay in place. Okay, this is what you think about when you think about a flat soda. You pour yourself a cup of soda, you forget about it, it gets warm, and all of the bubbles are gone, and you end up with flat soda. Okay, the bubbles, the carbon dioxide, has left the liquid. It actually came out of solution. It was mixed in with the liquid, and when you increase the temperature, the carbon dioxide leaves. And it's very hard to cause a gas to stay dissolved in something if you have the increased temperature, because the molecules and atoms are moving so fast. And remember, temperature really is just the speed of the molecules and atoms. Okay, secondly, we're going to talk about pressure. Okay, again, solids and liquids are different than gases. Now, when you talk about pressure, pressure has almost no effect whatsoever on the solubility of solids and liquids. And the question then is why? If you think about the structure of a solid or a liquid, the states of matter, remember that the atoms and molecules are very close together. So if you increase the pressure and you're pushing on them, there really isn't much you can do to it. It's not particularly compressible. Remember, that is part of the description of the states of states of matter for solids and liquids, is you really have almost no compressibility at all. So when you're talking about adding pressure, it's not really going to change the solubility. It's not going to cause molecules to be closer together very much. It's not going to cause them to go faster. Okay? So almost no effect. It changes it a little bit, but barely noticeably. Okay, now when it comes to gases, there is a huge change that happens because gases are easily affected by pressure. If you increase the pressure, you cause a significant increase in the solubility. And you can see on the left, you have the diagram of a gas and a liquid, and you have it kind of balanced. If you increase the pressure, what's going to happen is the gas is going to have less room, and it will be forced closer to the liquid molecules, and the gas is going to enter into the liquid. And as long as that pressure stays there, that gas will stay dissolved in the liquid. And again, when you think about soda, this is that situation. When you open that soda bottle, if you look on the right, when you open that cap, you're suddenly releasing the pressure. You're decreasing the pressure. So all of a sudden, the carbon dioxide that was dissolved into the soda doesn't have as much pressure keeping it dissolved in, so the carbon dioxide bubbles come to the surface and are released. And by the way, that process is known as effervescence, where those bubbles are coming out and kind of exploding on the surface like that. So pressure has a huge effect on what happens to gases. So just think again, when you open the soda can or soda bottle, what happens to the dissolved carbon dioxide? Now, this is a lab. It's officially the effect of temperature on the solubility of gases. However, you can see the effect of pressure as well. If you watch, you'll see what happens when he takes the cap off. That's the reduction of pressure. And he's going to show the experiment in 3 different temperature ranges. Very cold, room temperature, and at least warm, if not hot. Okay, enjoy the video and learn something from it.
Hi everybody. In this demonstration we're going to be looking at factors that can change the solubility of a gas in a liquid. The gas that we're using is carbon dioxide, the liquid is water, so we're using a bottle of seltzer water, which is bottled at very high pressure, pushing carbon dioxide molecules into solution in the water. So what we're going to be using are 3 different bottles of seltzer water. I've got one that's been sitting out at room temperature, another one which is in a warm water bath, so we're heating that seltzer water up. And then finally, the third one here has been sitting in a large beaker with ice water in it. So we've got seltzer water which is really cold, seltzer water at room temperature, and seltzer water which has been heated up to quite a warm temperature. So we're going to take a look at what happens when we open these bottles. So this is the seltzer water which has been left out at room temperature. So I'm going to go ahead and open this up, and let's take a look, see what happens as I open the cap here. Okay, so we can see that it fizzed up quite a bit, and what's happening right now is the carbon dioxide molecules which were dissolved in the water are coming out of solution. So that's producing the fizz, the bubbles that we see. And I kind of made a mess here, so I need to clean up before we look at what happens to the bottle that was in the cold water versus the one that was in the hot water too. Alright, next we're going to take a look at what happens when we open the seltzer water which was placed into the ice water bath. And just so we can see this a little bit more clearly, I'll just wipe off some of the condensation that's on the bottle before I open it. So we'll try to do that quickly, just to remove some of that condensation so you can see what happens here. Okay, so here we go. We're now opening the seltzer water bottle that was placed into the ice water bath. We can see that the carbon dioxide, which was dissolved in the water, is coming out of solution. We want to think about comparing how rapidly is the carbon dioxide coming out of the water when it's cold versus how quickly did it come out of the water when the water was at room temperature. Not as big of a mess to clean up this time. For the last part of this demonstration, let's take a look at what happens when we open the seltzer water that was placed into the hot water bath. I think I might get messy on this one. Let's see what happens. Okay, my custodial staff is not going to be happy with me, but hopefully after seeing this demonstration, you get a better feel for how the temperature of water can change the solubility of a gas in the water. Thanks for watching, everybody.
Okay, and next time we will continue talking about how different things affect the solubility of solids, liquids, and gases in solution.